Hello, good evening, viewers. You are highly welcome. Let's see. We are going to solve this problem here. This is called Tetration Equation. So now, in our previous classes, I've actually solved this problem here, but I made a silly mistake. I'm very sorry for the viewers that are watching. So now, this is the corrected version of this video. So I would like you to pardon my mistake, and let's see how we can do this in a beautiful way. So now, first of all, we can see that this is 3 tetration x tetration 2. Why the tetration is like the opposite of exponentiation. So we know that when you have something like a to power 2, a to power 2 is same thing as a times a, that is the repeated multiplication of a, where a multiply itself how many times? 2 times. Okay, so that's what you're going to have. Okay, so that's what you're going to have. So now what we're going to do next is that is in exponentiation. So now if you have a to power or a tetration 2, this one is like a raised to a. If you have a tetration 3, this is a to a to a. Can you see now? So that is the difference between exponentiation and tetration, right? So therefore what we are going to do now is that we have tetration in the right hand side, but this in the left hand side, so in the right hand side we have 27. So how are we going to do? So now I can rewrite this right hand side in this form, but let me write this first. We have 2x3 then equals, now I can rewrite this 27 in this, that is 3 to power 3, because when 3 multiply itself 3 times, we're going to have what? We're going to have 27. Now since we have this left hand side to be in tetration form, and according to what we have here, can you see 3 raised to itself, though let's now relate it with this one here, that is a squared equals a raised to power a. So now we have 3 raised to power 3. Now writing 3 raised to power 3 in tetration form, we're going to be having 3 tetration 2, right? Then we have 3 tetration x, then tetration 2. Do you understand? So from there we can see that we are having the same basis. We have 3 here, we have 3 here. So this is telling us that we are going to, this implies that x tetration 2 equals what? Equals 2. Do you understand now? So now another thing we are now going to do is that from here the left hand side is what? Is tetration. Okay, now let's go to write this in exponential form so that we'll be able to solve this further. So now having this, now let's go back to this. We have a to power 2, x to power 2 here. A to power 2 is a raised to a, so we can write this as x raised to x, right? Which is equals what? Equals 2. Now I have this equation. Now this is the equation that is the exponential equation that we are going to solve to get the value of x, right? So now the only thing or the only method we can use here, okay, is going to be Lambert W function. So we are going to be using Lambert W function. Now this Lambert W function states that when you have W phi of e phi, right, is going to give us phi. So what we are saying is that when you have a phi multiplying e to the power of phi, you're going to have phi. That is, if you have any number here that is that serve as the coefficient of e, must also be what? Be the power of e, and you must have what? You must have that number. That is what a Lambert W function states. So we are going to be writing this equation 2 or equation star in this form. So now having it like this, so what we are going to do is we are going to start from here. We have x to power x equals 2. I can take the logarithm of this equation by taking the ln of x to power x equals ln of 2, right? So from there this x will come down. We have x ln of x equals ln 2, right? So now from there I want us to do something here. If you have e ln x, this will give us x. This e, we actually cancel out the lane. They are inverse of each other. Okay, so therefore, but because of this Lambert function that has this e here, we're going to write this x here in this form. That is, we're going to have this to be e ln of x, right, equals ln of 2. Then don't forget that we have this x here, ln x here. So now ln x can, because it's multiplication, I can bring it out here. I can be ln of x. Can you see now? So we have ln of x, which is this one, then the x here, which is e ln of x. That is, we write it in this form. So now we can see that we can see our e here now. So now, as you can see, we see ln of x be the power of e. Okay, ln of x be the coefficient of e. So this is telling us that we can apply what we call Lambert. Okay, Lambert. Okay, we can apply what we call Lambert function of what, ln of x. So we apply this on this equation here, right? So now from there, so we now go back to the Lambert W function. When you have W, phi e phi, we give us what? We give phi. So the same thing, when you look at this, you have ln of x, ln of x here. So definitely this will give us ln of x. You have the solution to be ln of x equals W ln of 2. So now from here, we are not looking for ln of x. What we are looking for is x. So now to get rid of this lane, we're going to take the e of both sides. This, we cancel this. We are left with what? We are left with x equals e w, that means ln of 2, right? And that is the solution. But you can still rewrite this equation in another form. That is, when you have something like this, when you have this e, because of this exponential, if you have e w, let's say, of phi, is going to be phi over w phi, right? So phi is like the function here. So like we are having ln of 2 here. So therefore, if I want to write this, I can have my x now. X is now going to be, so now this phi will replace the ln of 2. I have ln of 2 divided by w ln of 2. And that's the solution. Okay, so now we have this, the value of x to be ln of 2 over Lambert function of ln of 2, or you said x equals e raised to power w function, Lambert function ln of 2. Then also we can have the approximated value for the value of x to be this on the board. Thank you so much for watching. Bye bye.